I'll discuss a useful problem from Pathfinder optics problem. It's excellent problem. I will rate it very high. We have a situation where you have a paper on which you have horizontal lines, a paper having horizontal lines, ruled book, and you place in this region I place a cylindrical object made of glass. This how I just don't place it horizontally. I placed it at some angle with the lines, ruled lines of the paper. This is the situation. So this is axis of the cylinder which is placed. It is circular. Let radius be r. Nothing is given this in this question. No dimension is given other than two angles, and you have to find the refractive index. I'll explain what the problem further says. Problem says that when you place it on the ruled copy, these lines appear inclined here, and they make this angle phi with the ruled lines, and this angle is theta. Theta is the angle made by the cylinder with the lines, and phi is the angle made by the new lines with the original lines. Means lines as you see when you see through, and you are seeing it from the top, as if I am looking at it from the top. So first part of the question says why it appears like this, which is not difficult, but the second part is very interesting. It says that with this information available to you, and assuming that it is not very thick, only that much it says, you have to find what is the value of this mu, only based on this information. So there the problem becomes very interesting, and the magnification which we have read, so most of you know, is v upon u. But how do you treat this? This is when you have these kind of conventional thin lenses. But in this kind of situation where you have one medium, ray is traveling from one medium to another medium, say mu1 to mu2, and you have object and image, or it can be reverse, then what is the formula for magnification, and how do you derive that formula? The derivation also I'll partly do, because it is useful. Now coming back to the problem, why the lines are appearing inclined. Now to explain it, let us take a situation where there is a cylinder, same cylinder, and I have cut across the cylinder. I have placed basically a plane passing through the axis of the cylinder. Don't confuse this axis with the optical axis of the lens. So far we say that in this spherical lens, this is the optical axis which passes through this. This is your optical axis. But this is the axis of the cylinder, so don't mix up with the optical axis. Now this plane is passing through the axis, and somebody is, say, observing from here. There is an observer here. I have just enlarged it, though it's a very small situation. Suppose I place here object, one object I place. The one object is placed, and it is seen this is nothing but a lens, and this object is placed very close to the lens. Naturally you will have a virtual image only. I'm just trying to explain in simple terms. So this image of this will be enlarged, so somebody from here will be seeing, if let me draw a line where I will place the objects. So this is the line where I place the objects. So let me place one object. This is 90 degree, three-dimensional. It is shown inclined. This on this line I place various objects of different heights. This is one height of the object. I place another object of another height. I place another object of another height, and here I place a very small height. Now somebody who is seeing from here will see the magnification. All of these are magnified. So this is magnified by some length. This magnification is based on the original length. So this is magnified by some length. This is magnified, and this is magnified. So if this was the original height, the new height of this series will be like this. Instead of these limited objects, I can have a rope here now, making this angle with axis This rope was making some angle with axis, say this angle be alpha, and now this rope, which is seen as an image, makes some angle beta. So if there is something which is inclined as far as this axis of this if the cylindrical body is concerned, its image will also be inclined, but at a greater angle because of the magnification. So now come back to the original problem. Let me draw the original line here. The original line is going straight, and this was the original line. This is the original line, and this is the axis. So from the axis of the original line, somebody who is seeing from here, I will just take, say, 3 points on the line, 1, 2, and 3. These are from optical axis at some height. This is the height of the optical axis, from the optical axis. When somebody is seeing it, these were the heights of these points which were on the line from not optical axis, axis of the cylinder, sorry, not the optical axis. I am seeing it perpendicularly now in the same situation. So height of each will increase by something. So this now takes, so if there was a line here, this line goes like this. So correct thing would be this line makes some angle. Now this angle is given as phi. Let me draw another diagram. Now I will use this concept. This is just the explanation. This concept to write the value of magnification. Then what happens to the magnification in case the medium changes, what formula we have to apply. Now here you see in a bigger kind of a diagram, this is the same lens or cylinder. This is the axis, and this was the original line, dot 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 dot. This is how it goes, and this is the height. These were the heights of these objects. These are now series. I am just taking a couple of them, and this angle is given as theta, was this angle which is given. Now the heights which appear here are like this. Each one is magnified, so that is how you arrive at, and this angle is given. So this is the line which is made, image of the line which is made. That was dots for the original line. This is the new line which is coming. Something like this will come. Some exaggeration I have done. I have drawn magnification, I have shown more, but magnification will depend. Each one has different lengths, so each one will have different extended parts. So this is how this angle is made, and this angle is phi. Now take any triangle, take any. This was the original height, and this is the new height. So if this is h1 and this whole is h2, so, and this is base of the triangle, so tan theta is h1 upon base, and this whole angle is theta plus phi. Tan theta plus phi is h2, the new height, upon base. So h2 upon h1 is equal to tan theta plus phi upon tan theta, and this I am showing the magnitudes. So the magnitude of magnification I can write as tan theta plus phi upon tan theta. In fact, since all are in the same direction, even if I write without magnitude, it is okay, upon tan theta. So this is the value I can write, because all were positive. Instead of magnitude, I have written along with the signs. Now this is one part of the problem. You can't solve this problem by writing m is equal to v upon u and then trying to find out what is v and what is u. It can't be done like this, because it is a situation where you have two mediums. if you take this lens, cross section of the lens, or let me rub the upper part, it is not required. So if you take this is that cross section of the lens, this is the axis, and just touching this side you have some object. These lines are there. I'm just taking the one which is just very near. Some approximation you have to do, and the mu which you get will also be approximation. So, and somebody is seeing from here. That is the situation. There is some height. The line is inclined. Line is inclined. That part we have already solved. Now we are solving what is magnification for the various heights which we had drawn. Suppose there is one object, what is the magnification formula we have to use? Forget the inclination here. Inclination is there because different objects are of different height. That gives the inclination. And the image was coming like this. Now I am taking out of this, I am taking only one. Having height, say, height of object, I want to find height of image and the relationship of height of object to the height of image with the magnification, that is u and v. Can we use this formula or we need a modified form? This is the situation where this is twice r. Now before I find what is the location of v, u I take just touching the lens. Some part is of course touching the lens, the other one are just nearby, so I take just this point for convenience for me. So u here is nothing but 0. Before I derive what is the value of v, let me explain the magnification formula which I will apply when I derive v and u. So just for a moment pause this thought and come to this thought. Now I am just drawing a general magnification in a case where there is change of medium mu1 and mu2. Here the object is just placed at the point of the lens, so this is my medium. So change is from mu to 1. This is how this change is happening. Here for this surface u was 0, v is 0, u and v both are here only. But when you come to this surface, u is equal to minus twice r for this surface. And for this surface now medium is changing mu to 1. What is the magnification formula we apply when this medium changes? Not the simple case of lenses where you go from this to this. To do that, I have taken a general situation. One is mu1, another is mu2. A general formula which will be applicable in other cases also. And I will apply that formula for this surface now. This is already done, u and v are 0. Now I will treat for this surface, u I know, I have to find v, and I should also know when there is a change of medium, what is the magnification, transverse magnification we use. So let there be some object h, let its height be h1, and to draw images in this case, in such cases it's always convenient to have a radius which is sharp curvature, and draw straight line passing through the center of curvature, means along the radius. This line you draw, this is 90 degree because the one which strikes normally will go straight. Draw another line which strikes this center, this so-called optical axis we can say, and this is my eye angle. It will get refracted like this. Let me have a sharper thing. It will go like this, and this angle is r. This medium is mu1, this medium is mu2, so mu1 I is equal to mu2 r. Snell's law, sin I take I, sin r I take r. So one formula we know. Now this will make, I am not deriving Lensmaker formula, I am deriving only the magnification when you have change in medium. This is height h2. What is magnification here is h image upon h object. and here H image is minus H2 and at H object is H1. This is above, this is below, so this is correct. If I write with sign, this is how it is. Now see, I can't write here M as V upon U. Magnification is basically related to the height of image and object. This is only a secondary derivation. You derived from this derivation in normal cases. But here it don't write V upon U. Let us see what it comes. Now mu1 I is equal to mu2 R is one relationship. Now see this triangle. All angles are small. So H1 will be equal to, this is say U A, and this is where the image is formed. Let me call it as VA. So U here is actually, U here is minus UA and V is VA. When I write along with sign, these are general terms, and when you put the magnitude, always put the sign. These are the magnitudes. Now value of H1 is equal to, you can write I times UA, that is the magnitudes. Here when you write M is equal to minus H2 upon H1, then it is the magnitude of that. So magnitude of H1 is IUA, and magnitude of H2 similarly you get as, this is H2 and this angle is R and this is VA. So R VA. So magnitude of H2 upon magnitude of H1 is equal to, these are all magnitudes, is R VA upon I UA. And what is VA is V. R upon I write like this. VA is nothing but V, and UA is minus U. And what is this? H2 upon H1, magnitude of H, this was M was minus H2 upon H1, and here this is that minus H2 upon H1. So this is nothing but minus M in our case. So M becomes minus this, M becomes R upon I, V upon U. You could have simply done with magnitude. I am just doing as per the magnitude and the sign both, because this is how you will find it in the books. Now what is value of R and I? R upon I is, now M is simply RV upon IU. What is value of R upon I is mu1 upon mu2. R upon I is mu1 upon mu2. Mu1 upon mu2. V upon U is the formula you should just memorize. Mu1 V upon mu2 U, and here you have to put the values with sign. This is the general formula. I have arrived at a general formula. Mu1 upon mu2 V upon U is the magnification when medium changes. Now I will use this formula along with other values which I derive now here. Now in this case, for this surface, as I said, it is done. For this surface, U is minus twice R. Let us find out what will be the value of V. Now general formula N2 upon V minus N1 upon U is N2 minus N1 upon R is the most important formula. Let me write R as R0 so that it becomes the magnitude part. Here it is general. So always better when you put the values here, put some notation so that it is not confused with this. Here it is without sign. Sign has to be added. When you put the values, everywhere sign has to be put. Now I am going from this medium to this medium. So N1 is mu and N2 is 1. So 1 upon V minus mu upon U is equal to 1 minus mu upon, what is the value of R for this surface? Radius is going in the opposing direction. This I am measuring from here, it is going opposing direction to the rays which are coming. So R is minus R0. Minus R0. One has to be very careful. So 1 upon V minus mu upon U is equal to mu minus 1 upon R0. What is the value of U? Is minus twice R0. 1 upon V becomes mu upon, and this is the value of mu. U is minus twice R0. I put the plus sign here because of that, twice R0 is equal to let me put it like this so that I can solve it. Twice mu minus 1 upon twice r0. So 1 upon v is equal to 1 upon twice r0 twice mu minus 2 twice mu minus 2. There is some error here. It was twice r0 minus u was negative, so value of v twice u minus 1, it's okay, twice mu minus 2 minus mu, it's okay, there is no error. So 1 upon v is equal to 1 upon twice r0. I get mu minus 2. So I get value of v as twice r0 upon mu minus 2. This is the value of v. And what is the value of u? Is minus twice r0. What is the value of m? M is mu 1 upon mu 2 into v upon u. Mu 1 is mu here. So mu upon 1 into v upon u is twice r0 upon mu minus 2 into minus twice r0. So it becomes minus mu upon mu minus 2 is m. Now simply equate it. So minus mu upon mu minus 2 is equal to tan theta plus phi upon tan theta plus phi upon tan theta, and I should get, let me just remove it, minus mu tan theta is equal to mu tan theta plus phi minus twice tan theta plus phi. So I get twice tan theta plus phi is equal to mu tan theta plus phi, let me remove it, mu tan theta plus phi plus tan theta. So value of mu you get twice tan theta upon tan theta plus phi plus tan theta is the value of mu, you get the final answer.